Hello and welcome to the Data Engineering Podcast, the show about modern data management. Atlan is the metadata hub for your data ecosystem. Instead of locking your metadata into a new silo, unleash its transformative potential with Atlan's active metadata capabilities. Push information about data freshness and quality to your business intelligence, automatically scale up and down your warehouse based on usage patterns, and let the bots answer those questions in Slack so that the humans can focus on delivering real value. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, to learn more about how Atlan's active metadata platform is helping pioneering data teams like Postman, Plaid, WeWork, and Unilever achieve extraordinary things with metadata. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Gopal Erinjippurath about his work at Sust Global, building datasets from geospatial and satellite information to power climate analytics. So, Gopal, can you start by introducing yourself?
Tobias, great meeting you today, and thank you so much for having me here. Everyone, thank you for listening. This is Gopal. Quick introduction. I'm an electrical engineer turned geodata scientist. My passion and expertise has been in geospatial data over the last several years. I started the early days of my career working on multimedia and large-scale imagery data sets. And along the way, got really interested in environmental data and got fascinated by remote sensing data sets and made the transition from large-scale imagery to large-scale geospatial data sets. And through a serendipitous sequence of events, ended up leading analytics and insights at Planet Labs, where I spent 3 years prior to founding Sust Global. While I was at Planet, in addition to exploring remote sensing imagery, I was also curious about what kind of data sets exist on the changing climate. And I essentially saw the emergence of frontier climate models. And that got me interested in climate modeling. And a couple of years back, I stepped in at full steam ahead with founding Sust Global and exploring large-scale climate data sets and climate models. So Sust Global was founded with the mission to develop data-driven products that enable every decision to be climate-informed so that humanity can thrive on the forward-looking, changing planet. And I would say the last several years of my career have been focused on product engineering and research commercialization on data-intensive applications.
And do you remember how you first got started working in the area of data?
Yeah, so my first experience working with data was looking at imagery. When I was at Dolby in 2007, 2008, I'm not skipping a decade here, it was a long time ago. Dolby decided to make this transition from being the world's foremost and pioneering audio technology company to being the world's pioneering multimedia technology company. It decided to invest into an imaging initiative, which led to a focused effort around building the world's first flat panel display for cinematic imagery calibration in studios and post-production houses. So that's when I started dealing with large collections of imagery data for cinematic reproduction. And as you can imagine, a movie file has many images. And if you're looking for products that scale across the gamut of cinema production, then we're dealing with a lot of imagery for calibration and for tuning. So that's when I first got started with data-heavy capabilities.
And you've mentioned a bit about what Sust Global is and some of the story behind how you got involved in it. And I'm wondering if you can talk a bit about the type of audiences that you're focused on as far as the products that you're building and the data that you're working with.
Yeah. We're primarily serving two camps of very motivated, climate-aware personas at the moment. So one of them is around ESG, assessment and reporting. As you're all aware, there's been an increasing interest as well as increasing awareness, environmental, social, and governance indicators. And oftentimes when you're doing those assessments, You can need the best, validated, cleanest climate data that you have access to. So reporting on the risks to a company from the environment, one of the avenues which we help our customers assess. Secondly, we've been enabling the creation of new sustainable finance instruments in the market intelligence space. So that's the second camp of analysts and data scientists whom we're enabling with clean, validated climate data. And then I would say there's this emergent third camp, which is rich sets of climate aware dashboards and insights platforms that are trying to surface climate data in interesting ways. So that's a little bit more nascent of a camp, but quickly emerging, and one that we are equally excited about.
Climate is definitely part of the zeitgeist right now. There are a lot of conversations happening around it, but the sort of concrete aspects of it are being able to understand what it is, what are the changes that are actually happening, what are the impacts that they're having on, business, on communities, on geographical elements. And I'm wondering if you can talk to the types of data sources that you're working with and some of the kind of scale that you're dealing with, some of the maybe heterogeneity that you have to deal with, and some of the ways that you're processing that data to be able to build some of these derived data products that are more consumable for your customers.
That's like a non-trivial exercise. So when we started out looking at physical climate risk data, and this is a distinction worth making clear. When you think about data in the context of climate, it's like an ocean, like there hasn't been another. You're looking at social data, which is human footprint and how that affects climate. There is economic data, which is, how has climate created the changing environment, and the changing climate created losses, and how that even loosely connects into the environmental footprint that is changing, that is enabling new schemes for carbon capture or for reduced carbon emissions. So that connects loosely into the carbon offsetting space. And then you have physical climate risk. And that's the space we operate in, where it's an understanding of what the environment is doing to humans, to property, to the land ecosystem, to the oceanic ecosystem. So over there, we are looking at assessments across physical hazards, which are both acute and chronic. So think of acute hazards as wildfires, riverine flooding, coastal flooding, flash flooding, and cyclones. And then chronic hazards being heat stress, water stress, sea level rise, like impacts. So in order to do each one of these hazards correctly, you have a subsystem of different or sub-collection of different data sets that we need to bring together. And what is the common ground there? So we can start there, which is inherently climate is a geospatially non-stationary process. So different parts of the land ecosystem are affected very differently by very different hazards. So the data sets are inherently geospatial and have spatial context. The second piece is they have a temporal element, because there is a different incidence of these events over the course of time, and also projected differently over the course of time. And together, there's no one model of like the entire Earth system. There are so many different subsystems to be taken into account. So bringing those together requires geospatial data transformations, and that's what we've been focused on building. So we tap into Earth observation data sets primarily because they are good ground truth for what is happening on the ground in the context of these physical hazards. And then we tap into frontier climate models that project into the future on what could be potential impacts and exposure across different climate scenarios, which is kind of loosely nominated by the IPCC based on their most recent reports. So if you look at projected capability and couple that with observational data sets, you can then look at hindcasts that help calibrate models against each other. So that's kind of the basic framework we are starting with. And built on top of that, we have at Sust, we have built a more sophisticated geospatial data processing stack that brings into account land layers, brings into account machine learning models, so that you can enable asset level assessments of physical climate risk. So going back, going from refining climate data to physical climate data to existing data sets to what is meaningful is a journey. And I would say the primary gap that we're trying to fill is this. When you look at frontier climate models, especially the ones that are global, and we think climate is a global problem, we want to start with assessments at a global scale. Global climate models inherently are meant for understanding fundamental variables and impacts at a global scale, but they're very coarse resolution. And when it comes to businesses that we are serving, they don't care about whether a country is at risk or like a state is at risk. Well, they do care, but they care a lot more about what's the impact of my holdings to my assets on the ground, my physical footprint, or my physical supply chain. So bringing it down to asset level and regional level on demand is the capability that we need to stand up. And that's where you need to use these data transformations and machine learning techniques.
I can definitely imagine a whole host of challenges and potential approaches that you could take to being able to do things. There are whole businesses that are focused on some of these subcategories of problems of, saying, okay, based on public records data, I'm able to determine that this, bounding box at these latitude, longitude key pairs are a physical kind of business that a company owns, and being able to identify that company and the entity resolution aspects. Like, talk to people where that's their whole business, is just that piece of it. I've talked to people whose whole business is just being able to say, I can handle this mapping layer and be able to overlay some of this kind of, social and civic data on top of these, raw map tiles to be able to give you some ability to analyze some of this information. That's a whole business right there. And you're saying, okay, we'll take all of that and add another layer on top where we also want to be able to understand what are the actual weather events, what are the long-term trends, how does that map from, discrete weather events into the overarching climate challenges. So definitely interested in understanding kind of how much of the technology stack and the data manipulations that you're doing are things that you're able to pull off the shelves because other people have kind of treaded some of that ground for you, and how much of it is just we have to build all of this ourselves and invent new technologies because what you're trying to do is so kind of vertically integrated and complex and inherently needs to be able to address all of those concerns at the same time.
That is a trade-off. And I feel in this particular context, we are building on the top of years and decades of research and work. So, climate models that exist today are kind of nth generation, like I like to call it. The IPCC calls them CMIP 6, or the couple model intercomparison project version 6.0, but they're built on top of generations of climate models, some of them written in Fortran like many years ago. And there's a lot of science and gifted thinking that goes into them. So rather than reinvent that, we've been focusing the problem more on how do you make that data meaningful to a business on the ground? Same thing with remote sensing. Like if you look at Earth observation data sets, there's just been an explosion in the context of like the amount of data generated from satellites in space. So finding the right data sets, the right sensors that can be used most effectively for data sets is kind of where we're in a very opportunistic time to be able to make those choices. So that's kind of where we have focused our time on.
In terms of the ways that organizations are using these data products that you're building, you mentioned that they want to understand, okay, what is the overall impact of climate on my assets, my physical holdings? I'm just wondering if you can talk to the types of questions that they're asking and some of the ways that you think about structuring your derived data products in a way that allows them to be able to explore those answers.
My role at Sust Global is a deliberately crafted, unique one. I head up both the tech and the product functions. And primarily it comes down to, okay, let's build the right tech and invest in the right technologies necessary to answer very, very specific and very meaningful sets of questions. So I would broadly set questions and the query set, if you might, for climate data or physical climate data into like the 4 camps. So the first set of questions is around localization and reporting. So where is there clear concentration of climate exposure, and what is the expected severity? What is the estimated impact to my set of assets? So that's like one set of questions you can answer, which is given a large collection of globally dispersed assets, where's concentration, where is exposure, and what's the estimated impact? So that's one set of questions we help answer. The second one is I would call relation, which is how does hazard exposure from the physical climate lead to impacts in either the distribution, the sourcing, the supply chain, or even the allocation of capital? So that's the relation set of questions. The third bit, I would say, the third camp would be what I like to think of as optimization. So if you were to deploy capital across a set of instruments or a set of assets in a climate aware fashion, how would you do it? If you were to deploy capital towards building new infrastructure, which is going to happen over the next few years, and make that new infrastructure informed by the changing climate, how would you do that? And how would you make those climate aware investments? So that's the optimization set of questions. And then lastly, I like to think of the camp of adaptation, which is how could teams of users and our customers introduce adaptation measures in a capital efficient way to protect structures, species, land, and natural capital for the decades and generations to come. So at Sust, at the early days of helping our customers build the understanding and awareness, and that's largely the reporting. That's where the market's at today. But longer term, we are building the software of climate adaptation. We're building the pathway from answering the basic questions, which is localization and reporting, to relation and optimization that help you connect to larger scale problem sets and larger scale business impacts, and eventually to adaptation, which is kind of where the world needs to be in the years to come if we are to be serious about adapting to the changing climate. And that's the software we're building.
One of the interesting aspects of this, too, is the question of education, where because climate modeling is a very sophisticated undertaking, it does require a lot of contextual and domain knowledge to be able to interpret all of the ramifications of the information that you're generating. I'm wondering how you think about the customer education aspect of the product that you're building and being able to say, okay, this is the information that we're producing. These are some of the ways that you can and should be thinking about aggregating it, because as with anything that you're doing with analytics, there are certain transformations that are legitimate and actually do provide additional kind of meaning and nuance to a problem. And then there are other ways that you can run an aggregation that, while it will produce a result, doesn't actually make any sense. And I'm curious how you've approached that challenge when working with your customers to be able to say, okay, these are the data sets, these are kind of the contextual semantics around it, and being able to bring that into their own analytical stacks and their own data products to be able to say, okay, you've combined our climate information with your information about the amount of capital that you have invested in a building or the amount of inventory that you're storing there. These are the ways that you can combine them to be able to get a useful answer and useful insights out of it. But if you do it this other way, it's actually just going to give you a number that has no meaning to anybody.
Yeah, and that's a non-trivial problem, especially right now with so many misconceptions around the changing climate. Many of the times people misunderstand weather for climate. Many of the times people misunderstand hazards. Many of the time people misunderstand causality. So I would say the way we have looked at it, and we're still in the early days of doing this, and we haven't cracked it 100% yet. We've tried to work on what I think of as a common domain language, which is, okay, what are the basic set of primitives on which we can start conversing on this topic, this fairly sophisticated topic, without misunderstanding each other? And I would say that starts with data literacy. And in this context, it's climate data literacy. And I've seen what Valerie Logan and the Data Lodge have tried to do in terms of going to digital transformation and going through data transformations and enabling companies to do that as like a pioneer in that space. And I've tried to borrow some of those methodologies into what I like to think of as climate data literacy and climate data as a second language. So that I take on what are the primary sets of things people need to have a common understanding of, and distill that into workshops, hackathons, and deep dives we organize with our customers, because this is not an established domain. Many of the like outside of catastrophe modeling, reinsurance and insurance markets, like people don't really know what to do with this data, but they have the right motivations. And I don't want to trivialize that. I feel like I shouldn't say people don't know how to. I feel it's a function of you need an increasing awareness of the capabilities to be able to shape these solutions right. And towards that end, we create venues where data scientists, data engineers, and from the customer side, brought in with solution engineers and data scientists from our side, climate data scientists at our side, to create that shared knowledge base. And once you've done it a few times, you see the replicable pattern, and you can then create the knowledge base that helps make it easier to do it in the future. And to a great extent, almost any technology, like even data engineering, be it some cloud native capability or a new open source package, has kind of evolved that way, where one use case has been clear, it's been documented, and then you suddenly have a community of people relating to that same problem set and then growing from there.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. Digging into the technology stack of how you're designing and building your platform, I'm wondering if you can talk to some of the architectural elements there and some of the unique challenges that you've had to address, some of the, engineering that has been maybe most valuable, but also most kind of challenging or frustrating.
Yeah, I feel like the exciting as well as challenging elements are that of like building this climate data warehouse where you have the most relevant data sets. And I would say all the cloud providers are kind of going in that direction. They are having either the planetary computer system from Azure/Microsoft to like what's in the Google Earth Engine data sets today. But they're not quite there in terms of all the capabilities and the stack you need. So we've been focused on building on top of those capabilities towards a climate data warehouse, which is very specific to what we need, and keeping that fresh is a non-trivial challenge. Keeping that well maintained and organized is a non-trivial challenge. And then enabling a feedback structure where on-ground intelligence and intelligence from our customers can help us learn to keep that warehouse and focus updates to that warehouse effectively is another non-trivial challenge. We've also focused a fair bit on building a cloud-native workflow. So we have built a distributed data processing system in Golang, and we have spent a fair bit of time on building out data pipelines that can process global scale or planetary scale data for large collections. If you're studying the supply chain of a commodity, that's like thousands or hundreds of thousands of assets. So being able to process that is something we've been doing. And I would say we kind of tuned our system a little bit more for batch mode operations. So I would say now the challenge we're looking at is, okay, how do we also enable rapid translation and being able to focus more on caching and querying, because the use cases are expanding and customer sets we are serving are expanding. So there's some new patterns that we need to support. And I would say in terms of the technology, the most exciting thing that I've discovered through this journey of building out the platform has been building the operational efficiencies where you can have these live streams, be it through satellite or through on-ground sensing, get plugged into the warehouse very efficiently and retrain models on demand or on demand based on certain triggers you set. So we've architected a system, I would say the beginnings of a system that does that effectively, and we intend to build that out over the years to come.
To that question of sensing, one of the other interesting problems in this space is the fact that there has been so much rapid innovation and evolution of the sensing capabilities, where it went from you had to rely on government-owned satellite imagery that had maybe a daily update cycle if you were lucky, to having commercially owned and rapidly expanding satellite imagery capabilities with, different maybe wavelengths of light that they're dealing with, or, dealing with not just light-based imagery, but radio sensing or radar, things like that, that maybe have hourly update cycles in some cases, at least over certain geographies. That's another aspect, is the fact that there is maybe heterogeneity in terms of the update cycles for those different geographies, where maybe North America has a rapid update cycle. Antarctica is obviously going to be very undercovered because it's such a hard orbital pattern to maintain. And I'm just curious how much of that is something that you've had to engineer around or have to worry about, or are there ways that you're able to kind of normalize the problem so that it is kind of pushed to the boundaries and you don't have to worry about that all the way through to the kind of center of your systems?
Yeah, so you raise a very interesting point, which is when you have very sophisticated imaging capability, you have to deal with all these boundary issues. And the big point to take away here is raw satellite data is often not very useful in this context. So when in the context of satellite imagery, we often talk about these processing levels. So natively what a sensor captures is kind of what people like to call L1. And then there's a processed auto-rectified, which is normalized to the ground version of it, which they call L1B. And then there is a version which is mosaic, which is kind of what you see on Google Earth, which is your L2. And then L3 is a stacked version of it, which has the time dimension. So Google Earth changing every day. So one can think of planet imagery closer to that. When it gets to that L3 scale, where data becomes useful for the kind of spatio-temporal analysis that we are talking about, which is primarily what you need for geospatial analytics related to climate. We've specifically gone with data sets where that's either already available or very easy to derive. So that's kind of the qualifying criteria, which kind of immediately shrinks your data set space to a very select few. And then you add on top of that, you want global coverage, and then it becomes even simpler for you to make the choice. So we've tried to push the problem more upstream and focus more on the application layer, because that's the thing we uniquely know to do.
In terms of the ways that the data is presented to your end users, I'm curious what types of data assets you're dealing with, the shape that the data is taking. Are you delivering image data with overlays? Are you delivering tabular or semi-structured data? I'm just curious kind of what are the assets that your end users are actually interacting with to be able to then form their own analyses?
Yeah, so we currently serve two products. We have a data API product that provides a very structured, it is not imagery driven, it's largely asset driven. So it's tabular. By asset, I mean physical location driven, which is the request which conforms with the request that the customers make to our API. And then the second product capability is that of a dashboard, which you can think of as a thin client built on top of the API or the data API, which enables you to visualize the climate-related insights and serves the analyst or like the non-developer audience. So the data API basically allows the collection of insights and the serving of insights, which are pretty structured. So we looked at tiled data sets and essentially connecting this to spatial or web feature services or web mapping or web tile services, but those are things that we have on the roadmap for the future. Primarily, the data API is serving the analyst and the data scientist personas very effectively at the moment, because they have the geospatial metadata, so it's very easy to put on a map and visualize as needed. So the way we have tried to focus on that is on the API connected to, we've stood up a Python client and a collection of notebooks and make it very easy for people to visualize it in their own workflows. And that provides a quick start for any Pythonic development workflow. And for others, we can easily solution engineer and stand those up too.
Another interesting area to explore is in that question of performing analyses, there's always an element of forming a kind of shared understanding, building a story around the insight that you're trying to provide to the people who are interacting with that output. I'm curious what you have found, both you and your customers, as useful kind of patterns or lessons to be able to bring some of that shared understanding to the end consumers of that analysis, because of the fact that it is relating to climate data, which does have this a lot of people have this complicated relationship with that concept where, it's something that is both inherently local as well as global. And, everybody has a part to play in it, but everybody has their own kind of concepts about how they think about that broader global impact and global network of involvement.
I would say for our customers, the problem set is very clear based on the camps or the questions that I mentioned earlier. So I think the confusion is a little less on that aggregation. So if we provide data at the asset or property level, then it is very easy to group, sort, or aggregate the risk to the macro scale, right? So if it's like a issue of a security, then they can look at their footprint and come up with a consolidation. So we kind of work with them and enable them to come up with that logic. We have some patterns which we can obviously get them started with. So I think the confusion there is less. I feel it comes down to, based on your on ground footprint or the tangible asset footprint, your profile can look very different. There's also this element of background or benchmarks, right? So you might have an asset or a site or a property in an area which has very high exposure in the background. And you might not be much worse off or much different from the background. But that might still be highly elevated risk profile or exposure profile compared to another area or another site. So that context is often very important, especially in use cases around site selection, where you're confined to a region, but you're looking for the lowest level of physical risk exposure in that region. And that's kind of inverting the problem towards saying, okay, I know this is the region, but here's where, if I were to pick a parcel of land for a specific opportunity, where would I do that? So that's different from, I know this is the parcel of land I care about, what's the risk there? So you're kind of looking at both sides of that. So I would say that's macro versus the micro.
Another layer that people are, I'm sure, curious about is this question of kind of timescales, where you're looking mostly, I'm sure, at what is my risk right now? What is my risk projected into the near-term future, or as far out as I could reasonably predict? But there's also value in understanding, okay, I have this information about now, maybe near into the future, but what if I look backwards and I'm looking at annual timescales of what is the impact of climate on these locations, and being able to then build up that view of how have changes in the climate progressed from time into the past to where we are now, so that I can then get a more nuanced understanding of what these future projections actually mean for me, because I can build up this trend of analysis to be able to say from the past through to now into the future. I'm wondering what you see as ways that factors into some of these questions in the decision-making process.
Yeah, I feel like that definitely helps shape a deeper understanding, because what has happened is something people can relate to. What could happen in the future is something that is still unknown, and no model can say that with absolute certainty. So, being able to surface the data on the historic dimension and surface it at a cadence that can be correlated with other outputs and benchmarks is definitely very valuable towards developing a deeper understanding. So, being able to enable insights and indicators that are relatable in history help make those even more relatable for forward-looking projections. And the forward-looking projections is just hard, primarily because when you look at climate with a 30-year horizon, so many things that could change in that time frame. So that's the reason why even with the Sixth Assessment Report and the IPCC, they documented a set of bundled assumptions as what they call socioeconomic pathways or shared socioeconomic pathways, the SSPs. And that's basically saying, okay, if you make these assumptions, this is how you can enable a projection. So that ties into all the different warming scenarios indirectly. So that's kind of what you see in the climate literature.
Big Eye is an industry-leading data observability platform that gives data engineering and data science teams the tools they need to ensure their data is always fresh, accurate, and reliable. Companies like Instacart, Clubhouse, and Udacity use Big Eye's automated data quality monitoring, ML-powered anomaly detection, and granular root cause analysis to proactively detect and resolve issues before they impact the business. Go to dataengineeringpodcast.com/bigeye today to learn more and keep an eye on your data. And when people are building these kind of aggregate, layered historical views projecting into the future, are there certain kind of key indicators of the climate that they're typically looking at? Like, are they looking at what is the average kind of seasonal temperature and its variance over these years? Are they looking at, rainfall? Like, what are the types of kind of climate information that they're looking at? And how do you help to prevent the pitfall of looking at specific weather events in that process of building the analysis?
Yeah, great question. So I feel like it's oftentimes the questions start with like temperature and precipitation, right? These are more fundamental variables, but now we are seeing increasingly awareness around hazards, like the acute hazards, because it's immediately loss making, like because of certain increased cyclone risk in certain areas. People in the Gulf of Mexico, in Florida, are getting used to the fact that during hurricane season, because of heavy winds, they'll have to live somewhere else. So I almost feel that awareness is there. We're seeing that expand to other hazard dimensions. For example, heat stress and water stress. As you probably know, there's been this increasing water stress and drought across many parts of the US. And that's expected to just get worse as there's more warming. So what does that impact look like? So one of them is the absence of water, but then what about the businesses that are heavily dependent on water, like a mine or a bottling factory? And what does that look like across these scenarios, across these longer time horizons? And then if you were investing into those businesses, how would you think about the operational burden from drought and water stress in the future? So those are the kind of problems we're looking more closely into and enabling teams to answer. And in terms of weather functions, that's a lot more near term. And there are different set of solutions related to that, which we introduce our customers to. We're not trying to solve that problem. We're not trying to do weather or seasonal prediction, because that requires a different set of expertise.
Another interesting way to think about interacting with this climate information, particularly since you're looking at near future projections, is the question of being able to maybe play with some of the outcomes where you say, based on this action or the assumption that I'm going to act in this way and that in aggregate, people who are in my industry are going to have similar behaviors, what impact might that have on future climate projections, particularly if you're looking at industrial scale operations where you have billions of dollars worth of economic activity happening. If those players are saying, okay, based on the data that I have and my assumptions about future climate impact, I am going to actually make this investment in reducing my emissions by this percentage, assuming that everybody else in the industry is going to do the same. Like, how much of a kind of meaningful insight will that provide, and sort of what are the levels of scale that are necessary to be able to actually understand what type of meaningful impact might that have given these set of assumptions?
Yeah, I feel like to some extent the scenario you just laid out is the broad narrative for offsets. And what I mean by that is, and many of the times, there is the understanding that when you have heavy emissions, you're indirectly doing harm to the environment and triggering accelerated warming. So if one thing you could do is stop that, the second thing you could do is kind of offset that. And that's where I feel like the credit schemes indirectly, or the credit schemes enable businesses to be able to contribute back towards the system, the holistic system. But the big challenge in this ecosystem of assessments is the time frame. So if you're having heavy emissions today, so say you emitted N tons of CO2 into the environment, like nothing changes immediately, right? There might be some or N tons of CO2 equivalent. It might not be exactly carbon dioxide. Or you were involved in some wasteful process. The impacts from those are not apparent right away. It's apparent years from now globally, might not even impact your specific operation. So I feel for having a system of adaptation there, one, you need the climate mitigation measures, which are kind of carbon offsetting, reforestation, sequestration. And on the other side, you need the adaptation measures where you would think that the incidence of these events is going to increase over time. So balancing those out is kind of the complex bit. And the unknown is when you hit certain tipping points, the impacts can be a lot worse than right now. And the unknown is also what level of emissions trigger those tipping points.
In terms of being able to get started using the products that you're building at Sust, I'm wondering if you can talk to some of the assumptions that you have about the kind of analytical or data platform capabilities that your customers are working with, or the types of technologies or interfaces that you're able to provide, and just some of the overall steps involved in being able to get onboarded as a customer and be able to start taking advantage of the kind of derived data products that you're building to be able to incorporate into some of these business questions and being able to help feed that into the decision-making processes.
Yeah, so I would say some of the assumptions, there's always especially if you're looking at things from an API first standpoint, the assumptions are often a shared understanding of the data interface. Like how does data enter your system? How is data that you are serving back the customer used in their environments? So we've focused a fair bit on that, and we've worked through some early assumptions and some false assumptions that we've since corrected into the capability we currently serve. I would also say the way we have been able to work through those assumptions is just like most commercial APIs providing effective documentation, a solid API reference has been very useful that someone can actually pick up, read, and implement. Secondly, providing some good examples on how the data can be used downstream and integrated in workflows is another very valuable thing. So we've kind of gone in with certain assumptions, and then in cases where those assumptions are not 100% valid, we're trying to showcase how you can solution engineer around that rather than serve a bunch of features that we got to maintain over time. I'm sure that's going to expand over time, like we're going to have to build more, but we're trying to be very deliberate around the data capabilities we are serving because we want to serve it for the long haul. And inherently, if we're onboarding customers today, that's what they're getting used to in a production setting this year. And once things go into production, ideally, you don't want to change unless the use cases evolve.
In your work of building this platform and working with your customers, what are some of the most interesting or innovative or unexpected ways that you've seen your products used?
It was a pleasant surprise when we had a few teams looking at municipality level insights when it comes to city planning. And originally we didn't think of that as a use case, but that was an emergent capability. The second bit is around when you think about, you just touched briefly on carbon offsets, but one of the capabilities we spend a fair bit of time on in terms of fleshing out is a wildfire projection capability. So as you know, one of the examples of carbon offsetting is planting trees and planting forests. So if there were an afforestation or a reforestation project that is getting commissioned and funded, there's the assumption that when that forest goes live many years from now, it's going to suck carbon from the atmosphere. And based on the capacity of that, you're already providing offsets onto that project. Now, that whole assumption, that whole workflow assumes that the forest is untouched and thriving. But if you have forest fires, that's no longer true. So this is where the interaction between the urban wildland interface and wildfires directly impacts the efficacy of a carbon credit. And that's a use case that came from our customers, which is very innovative, that we really want to support because it really pushes the carbon credit ecosystem to the harsh reality of what things look like in the next 20, 30 years.
Yeah, it's definitely interesting and great that the information that you're providing is able to feed back into not just corporate decision making, but also a better understanding of the programs that have been put in place to account for climate change and the ways that people think about being able to mitigate risk or offset their own activities, and kind of digging into the assumptions and making sure that they are actually accurate.
Absolutely. And we're testing those assumptions and holding accountable like the whole process for credits. And I think that's largely what that ecosystem needs, because outside of a few standardization bodies, it's kind of like the wild, wild west.
And in your own work of building this product, building this business, working in this ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
So I would say one unexpected lesson is, when you're starting out with like a very small team or, just the team of founders, the first set of customers you onboard really shape the trajectory of your first few months or even sometimes first few years. So I would say most people talk about picking founders or investors when it comes to entrepreneurship. But I like to invert that and say what you care about the most is picking the customers you go after, because that shapes the narrative of whether you want to be self-funded or venture funded or related. The second bit is I feel founding Sust Global, I've been pleasantly surprised by the kind of learnings from cross-pollinating across remote sensing, data engineering, machine learning, and climate modeling, all of which are related. Data is like the common thread among all these domains, but they're all so rich in terms of context of the data that it's been a constant learning journey for myself and for my team. And building out an interdisciplinary set of individuals to come together on this shared mission has been a very exciting journey for me. And I've been also pleasantly surprised on what a small team of engineers can accomplish. And the other learnings being, we're looking at things with a fresh look and not be biased by what has existed before because we're operating in a different environment.
For people who are interested in accounting for climate information in the work that they're doing and in the decisions that they're making, what are the cases where Sust Global is the wrong choice?
I would say, like we touched on a little earlier, whether if you care about very near term days and weeks rather than months and years, then we're not the right solution. And if you care about, ESG is very broad. So if you care about social and governance angles, we're probably not the right solution. We're very focused on physical environment and physical risk at the moment.
As you continue to build and iterate on the products that you're building and exploring more of the space and understanding what are the questions that are being asked and ways that you can address them, what are some of the things you have planned for the near to medium term?
Our near-term focus is to get more developer-friendly. We're seeing a remarkable set of opportunities in terms of serving not just analysts and data scientist personas, but also developers who want to integrate our capabilities into new dashboards, new products that they're building. So more work there, new sustainable applications powered by SaaS. Sust Global's capabilities is one of the things we are planning for in the future. And then, going from hazard exposure to advanced adaptation measures, we're building the software of climate adaptation, and we're just in the early innings of that. So a lot more to follow on that evolution.
Are there any other aspects of the work that you're doing at Sust Global and this overall space of climate analytics and climate data that we didn't discuss yet that you'd like to cover before we close out the show?
I would say, climate impacts everybody and all aspects of business. So while we have been very focused on the commercial opportunities, we also live our mission. And in enabling humanity to thrive, on the changing planet with the evolving climate, we prioritize decisions that minimize even our own carbon footprint. And even when we pick external collaborations, we try to see if there are opportunities for us to collaborate with like nonprofits, enable them to have access to our data because it doesn't cost us much when you are still operating the same data stack, and thereby enable a net positive impact. So we've been very focused on that. And I feel like that's baked into our culture as a team. So as we onboard new individuals onto our team, as employees, as partners, as advisors, we look for that. And that's helped shape our DNA.
And as a meta note too, if you wanted to call out your kind of hiring efforts, this is a good time for you to do that.
Yeah, absolutely. So we are hiring for a senior backend engineer as well as like a lead platform engineer to help us bolster more of our platform and data engineering efforts. So if what you folks listening have enjoyed hearing, I would love to hear from you. And if you're interested in learning more about these roles, visit the careers page at sustglobal.com. Also, for any others who are working on large-scale imagery or environmental or climate data in the context of data warehousing as well as data processing work, if the problem sets that I've described are interesting to you, whether you're looking for new opportunities or not, I would love to stay in touch and talk more. So feel free to reach out. LinkedIn is the best place to reach me and find me. So direct message me there.
All right. Well, for anybody who does want to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
And that's a biggie. I would say when it comes to tooling and data management, people look at like data management, they're all looking at it from the lens of the tools they currently use. And thereby they go natively to the cloud provider and the tool stacks that exist there. So I would say some of those are already, from our perspective, we're familiar with the kind of tools and capabilities that exist. But the biggest gap would be looking across those tools, some of which are built within the cloud providers' environment and some of them which are not. So for example, if you're using Mixpanel for evaluating product metrics and Datadog for evaluating and for incidents management and incidents response, you kind of need to manage different accounts for them. So I would say having a holistic system where your data management as well as data metrics and insights management are all easy to do together, which is widely known and used, is one gap I'm seeing. I'm sure there is some solution out there which tries to solve that, but it hasn't become mainstream where I've seen that widely deployed. So would love to hear more about that too.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Sust Global and your efforts to help bring more visibility to the information about climate and the ways that it impacts businesses and their operations and the ways that they make decisions. So appreciate all of the time and energy that you and your team are putting into that. And I hope you enjoy the rest of your day.
Okay, thank you so much. It's been a pleasure to be joining you. And thank you so much for having me.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.